Hi guys, welcome back to my YouTube channel, Mazak Tips and Tricks. If this is your first time here, my name is Phil, and I teach people how to run a Mazak CNC lathe while programming it with Mazak. This next video is something several people asked about, and that is knurling on the CNC lathe. The technique I'm going to show you can be performed on any CNC lathe and is not specific to the Mazak control. Alright, let's get started. Alright, this is going to be our workpiece. It's an 1.25 inch aluminum stock, and I'm going to turn it down to 1 inch and then knurl the front of it. In this video I'm going to show you how to set the knurling tool to the workpiece, because you cannot probe a knurling tool, and then also how to program it, and then we'll run the part. And the first thing you need is a knurling tool similar to this. This is a CNC knurling tool. It is not the same as a manual lathe knurling tool. This one has very limited up and down movement, whereas a manual knurling tool, you can spin all the way around and it won't line up by itself on the CNC. So you need to get the proper knurling tool whenever you're knurling on a CNC lathe. I already have a different knurling tool already set up in the machine. It's slightly different from this one, but it is also a CNC lathe knurling tool. So, all right, let's get going. So the first thing we're going to do is create a new program. Go to Program, Program File, and select a work number that's not listed up here. I'm going to select work number 40. So go back to Program, push work number 40, input. If this is a new program, push the Program button. Mazak or EIA, we're going with Mazak. Workpiece material is aluminum. Max outside diameter of workpiece is 1.25. Inside diameter is 0. Workpiece length, I'm going to say 4 inches long. Max spindle RPM limit, this is the G50 for the entire program. So I don't want to run the chuck past 2,000 RPM. Finish allowance on X, this is for turning and not the knurling stuff. I need to turn it and face it to establish a knurling diameter. So finish allowance on X, I usually pick 10 thousandths on X, 5 thousandths on Z, and we're going to face the end of the part off. So we're going to go with 50 thousandths stock removal. First thing I'm going to do is turn on the coolant. Next thing I'm going to do is face the end of the bar off. And I'm going to use tool 6, offset 1 for roughing and finishing. And I'm going to turn the OD to a 1 inch diameter. Using the same roughing and finishing tool. So I'm going to say linear. Starting corner, I'm going to give it a 30 thousandths corner break. Final point on X is 1 inch. Final point on Z is going to be 1.25. And that's going to be good for right now. What I need to do is finish turn the diameter so I can probe. I need to finish turn the diameter so I can set the knurling tool X and Z on the workpiece, because we cannot probe a knurling tool. So I need to run this part of the program first, and then come back and set the knurling tool, and then continue on with the knurling tool. So I'm just going to end it right now. And now I'm going to set the work shift and then turn the diameter. So let's set the work shift right now. All right, we got to bring up tool 6. Move it over. Turn the spindle on. All right, stop. Go to Program, Program File. Z offset teach. We're 50 thousandths in front of our 0, so we type in 0.05 input. All right, let's go to the position screen. Auto, work number 40, input, and we're 50 thousandths in front of our 0. Here's our workpiece, and this is the face and diameter that we programmed. So store, scale, I'm going to zoom in on it a little bit. All right. So now let's go to trace. Now we can see our turning tool. We have the 50 thousandth stock. So let's go ahead and run this. Because it's aluminum, I'm just going to shut off the coolant for now. But when we knurl it, we have to use coolant. All right, here we go. All right, we are done with that portion of the program. Next thing we need to do, if you don't have the knurling tool installed, you need to do that now. So this is the knurling tool that we're going to use. It has a little bit of movement in it, but not as much as a manual knurling tool. So again, you must use a CNC knurling tool to do this job. So this is tool 15. So let's come over here to the tool set, or tool data. So 15, I have it described as a general out turning tool, and I have the spindle running backwards, and it's as a left-handed turning tool is what I described it as. So I described it as a regular CNMG turning tool, 95 degree, 80 degree diamond. This part really doesn't matter because I'm not machining it with a Mazak program. I'm going to use a manual process to drive the tool. And the biggest thing we need in there is the tool direction. Otherwise, the machine will sit there and it won't know what to do. So let's go down to the tool set. and we're going to teach the tool. So the first thing we're going to do is we're going to set the X on tool 15. So go to the position page, go over the part, bring it down gently until it touches the OD of the workpiece. But we don't want to cram it in there. We just want it to stop wiggling and have the rollers bite on the workpiece. So right now they're barely biting. So I'm going to call that 1 inch in diameter, because that's what diameter this stock is. So go over here to Tool Set, arrow over to the X, and push Teach 1 inch input. And now let's go back to the position screen, and the position screen will show 1 inch on the screen. So now what we need to do is back it off, move it over to the face of the workpiece, and this part doesn't have to be exact, but move it over to the face, just until the rollers start touching. Right there. And now we're going to call that Z0 on this turning tool. But we can't just call Teach Z0 on this machine. What we need to do is go to the program file screen, and we need to input the Z offset work shift into the tool data page to set this tool. So right now, this tool is 1 inch, or the Z0 is 1 inch 1112 in front of my tool probe 0. So I want to set this tool at Z0 for this workpiece, so I'm going to teach it with this number. So it's 1 inch 1112. So right now it doesn't have a geometry in the tool set. So teach 1.1112. Input. It taught the length of the tool, and now it shows the tool is at Z0. And it shows a 80-degree diamond because that's what I described this tool as, even though it's a knurling tool. There is no knurling tool in the Mazak tool file. So we'll back the tool off. Now what we need to do is finish programming the workpiece. So program, erase, input, down arrow, shape end. And we're going to push the arrows and go to the manual program. Exchange point of tool, we're going to put a 1 in here. So it goes to the tool change position. Gear number, on this machine we always have to give it a gear number whenever we're in the manual process. This machine will automatically select the gear to run in Mazak, but in the manual process you have to give it a gear number. This machine only has 1 speed, but you still have to tell it gear 1, otherwise it'll alarm out. We're going to use tool number 15. So the first thing we're going to do is rapid to a diameter of 1.1. The final point on Z. What we're going to do is we're going to start the tool away from the workpiece, and then I'm going to feed it in at an approximate 30 to 45 degree angle into the workpiece, I don't just go straight in. The wheels tend to track irregularly if you do that. I get better luck knurling when I come in on an angle, and then I'm going to feed across, dwell, feed back, and then come off the workpiece is how we're going to program this. So the final point on Z, I'm going to actually start knurling it about 100 thousandths away from the back. These knurl wheels are 200 thousandths wide, so I want to finish it at a minus 300 thousandths into the workpiece. So I'm going to start it at minus 0.1. No circle radius. The speed we're going to run it, I'm going to run this tool at 800 RPM. The speed that I'm running it at is good for aluminum for this diameter of workpiece. You can go faster, you can go slower. Again, knurling is kind of an art, so you're going to have to do some trial and error and do what works for you. On some controls, we need to put in the spindle direction in order to start up the spindle at 800 RPM. On this old control, we don't need that, so I'm going to skip it. We do need to tell it offset 1. So the next thing we're going to do is do a G1 move, and then we're going to feed it into the workpiece on an angle. And for this knurling tool, I know I typically want a 30 thousandths deep knurl on the diameter. So if I go 0.970, that's going to feed it 30 thousandths into the workpiece and give me a knurl. If I go to 1 inch, it's not going to do anything. So I have to feed it into the work to actually raise the material. So I'm going to knurl it at minus 300 thousandths, excuse me, minus 0.3. And I'm going to feed it in fairly quickly. I'm going to feed it in at 15 thousandths per revolution. And then I'm going to feed it across the workpiece basically to here, so I don't bang on this corner. Basically, this is just a test piece, but I don't want to crash into the knurl because the Z0 is on the face of the knurling tool that when I probed it, but this is going to be sticking out further. So right here, it's 1 inch 30 thousandths. So I'll just go to 1 inch. So minus 1, again, we're putting negative values because we're behind 0. Whenever we're programming with a manual process, the Z's have to be a negative value in order to be in the workpiece. If they're positive, they're going to be on the right side of 0 and not do anything. Feed rate, I'm going to put in 5 thousandths per rev. And then what I typically do, because the part needs to dwell, I'll put in a G4 dwell time of 3 seconds. And then what I'm going to do is feed it back to this dimension. And then I'm going to wrap it off the workpiece. And then wrap it away from the workpiece. And then shape end and end. So this is our knurling program. So let's go look at the tool path for the knurl. So go to Program, check and check continue. So it's going to face it, finish the face, rough the OD in one pass, 2 passes. So it's going to wrap it in, come in on an angle, feed over, feed back, wrap it up, and wrap it off. And I'm going to change the rapid so it comes up higher so it doesn't have any tendency to drag on the front of the part. So let's go ahead and change that to 2 inches. And let's run it again. There we go. So the knurling tool is going to come in, feed in on a shallow angle. It looks like around 15 to 20 degrees, which is totally fine. Feed across, feed back, and then come off. All right, let's go ahead and run it. All right, we're done. Oh, look at that. And that's how to knurl on the Mazak CNC lathe. If you guys like what you see, go ahead and push that subscribe button and click the bell so you won't miss any future videos that we have coming out. If you guys found this video to be helpful, please give it a thumbs up. That helps out my channel and gets YouTube to share this video with more people. Also, if you guys have suggestions for future videos, please let me know in the comments. Thanks again for watching.